Ask a brand new engineering cadet what keeps a massive ship running, and I guarantee they'll tell you it's the main engine. But ask a seasoned chief engineer, well, they'll tell you it's whichever piece of auxiliary machinery just failed. Welcome to this explainer. Today we're focusing on the true unsung heroes of the engine room, because while that giant main propulsion plant gets all the glory for moving the ship across the ocean, it's actually the auxiliary machinery that wakes that engine up, keeps the crew alive, and keeps the ocean clean. Literally, one small failure down here can be the difference between a perfectly smooth sailing day and a multi-million-dollar pollution fine.
To really understand the stakes, we need to internalize this idea. The ship is a self-contained industrial site. Every single utility that a facility on land would just get piped in from the outside has to be generated or treated right there on board. Think about what that actually means. When you're on land, you're connected to city water lines, a municipal sewer system, a massive electrical grid. But out in the middle of the ocean, there are no pipelines to tap into. These unsung machines have to replace all of those external city utilities, and they have to do it relentlessly in a highly corrosive, salty environment.
So, who are the ship's true MVPs? We've got four main ones we're looking at today: the air compressors, the heat exchangers, the evaporators, and finally, the environmental equipment.
Section 1. The starter. Air compressors.
So you can't just turn a key to start a massive marine diesel engine. You need a massive jolt of compressed air to wake up that giant. But compressing air to incredible pressures is essentially like squeezing a balloon, and it absolutely must be done in a specific, staged way. If you try to compress air in one huge jump, it generates dangerous levels of heat and stress. So instead, these machines compress air in stage 1, give it a much-needed cooling break, which is known as intercooling, and then they compress it even further in stage 2. It's a highly controlled, incredibly safe way to build massive pressure.
And the magic number you really need to remember here is 30 bar. After making its way through those stages, this high-pressure air is stored in heavy-duty receiver bottles at commonly around 30 bar. To put that into perspective, that's over 400 pounds per square inch. It just sits there, locked and loaded, ready to blast those massive pistons into motion the absolute second the order is given from the bridge.
Section 2. The balancers. Heat exchangers.
Okay, so engines get incredibly hot and need constant cooling, right? But you definitely do not want corrosive seawater running through delicate internal engine parts. So engineers use a heat exchanger. This brilliant piece of equipment transfers thermal energy between two fluid streams without ever allowing them to physically mix. There are two primary designs we see out there. First is the robust shell and tube type, which passes one fluid through a bundle of tubes inside a shell carrying the other fluid. And then there's the titanium plate type. This one stacks thin, corrugated plates to resist seawater corrosion, and it offers an incredibly high surface area and a really compact footprint.
If that's hard to visualize, just imagine a stack of baking pans. Now picture pouring piping hot soup into every other pan, and then putting ice-cold water in the pans sandwiched right between them. Because the metal is so thin, the heat jumps easily from the soup to the cold water. They're exchanging heat over this massive shared surface area, but the two liquids never actually touch each other. So your engine coolant gets chilled by the ocean, but it remains perfectly clean and salt-free. Pretty genius, right?
Section 3. The lifesavers. Evaporators.
Out at sea, water is quite literally everywhere, but there's not a drop to drink. Well, unless you have an evaporator turning that salty ocean water into pure, distilled drinking water. Now, boiling thousands of gallons of seawater sounds incredibly energy-intensive, but engineers use a really clever physics trick here. You know how your ears pop when you drive up a high mountain? Evaporators operate under a strong vacuum, using that same principle of pressure. Lowering the atmospheric pressure inside the unit lets water boil at a dramatically lower temperature, which means it can boil using only the lukewarm quote-unquote waste heat recovered from the engine's cooling jacket.
And the output from this trick is just staggering. Just a single evaporator on a mid-sized vessel can produce 15 to 30 tons of fresh water every single day, all by just using that waste engine heat. This elegant piece of engineering makes the ship entirely self-sufficient for drinking, washing, and boiler feed makeup. It completely eliminates the need to constantly load water at port.
Section 4. The defenders. Environmental equipment.
These machines are the ultimate defenders, standing between normal daily operations and catastrophic environmental damage. Down deep in the absolute bottom of the ship, bilge water collects. And it's nasty stuff, often mixed with leaked oils, fuels, and sludge.
Before that water can ever be pumped overboard, it has to go through an oil/water separator. This machine meticulously strips the toxic oil from the water using gravity separation, alongside coalescing plates that actually force tiny oil droplets to merge together and float to the top.
International maritime law, specifically under MARPOL, dictates a strict, uncompromising maximum of 15 parts per million of oil content in any discharged water. Think about that, just 15 drops of oil in a million drops of water. This is monitored continuously by a highly sensitive inline oil content meter. If that limit is even approached, the system automatically snaps the overboard valve shut and diverts the flow right back into the bilge holding tank. All right, I want you to put yourself in the shoes of the chief engineer for a moment. You're down in the engine room overseeing a routine bilge discharge, and you notice your inline oil content meter's reading is steadily climbing up toward that 15 ppm limit. Do you wait a minute to see if it maybe stabilizes and drops back down, or do you act immediately?
You act immediately. You must instantly stop that discharge and investigate. While the overboard valve is technically supposed to close automatically at the set point, a rising trend means something upstream, like a slug of heavy oil or maybe a failing filter, has already gone wrong. Waiting even just a few seconds only risks equipment damage and a severe discharge violation. You do not mess around with this.
And you really don't want a violation. Let me hit you with a reality check. Bypassing or falsifying these meters, which the industry grimly refers to as magic pipe incidents, is one of the most heavily prosecuted offenses in all of shipping. We are not just talking about a fine for the shipping company. It carries direct, personal criminal liability and actual prison time for the engineers involved. That is exactly why these environmental defenders are treated with the absolute utmost respect.
Section 5. Summary and Stakes.
So, by understanding these 4 crucial auxiliary systems, you now know exactly how a ship sustains itself as an independent, floating industrial site. Air compressors squeeze the air that jolts the massive engines awake. Heat exchangers safely balance those extreme temperatures without ever mixing the fluids. Evaporators use clever physics and waste heat to generate mountains of fresh water. And separators act as the final, unyielding guard, defending the ocean by strictly enforcing that 15 ppm limit.
Treating what leaves the ship carefully prepares us for what actually powers it. We've talked about cleaning the waste bilge water, but what about the lifeblood of the engine itself? How exactly do marine engineers purify thousands of gallons of thick, heavy fuel and lube oil using what is essentially a high-speed, spinning metal bowl? Well, we're going to uncover the amazing secrets of centrifugal purifiers in our next explainer. Until then, keep questioning how things work.